whole building mechanical ventilation systems. The references for this particular section is going to be the reference appendices, section RA 3.7, and that's the link you'll be able to find the document at, and as usual, it'll also be available on the LMS. The purpose of this diagnostic is to measure the airflow in mechanical ventilation systems to confirm compliance with the requirements of ASHRAE 62.2. These procedures are applicable to continuous and intermittent mechanical ventilation systems in low-rise residential buildings as previously described. The overall training goal is to familiarize yourself with mechanical ventilation testing equipment, protocols, and forms. These are the sections that we'll be covering in this particular PowerPoint. So let's get started with the equipment specifications, just like we did in the other sections previous to this one. Anytime you take a pressure reading for mechanical ventilation, pressure shall be measured with equipment having an accuracy equal to or better than plus or minus 1% of pressure reading, or plus or minus 0.2 pascals, whichever is greater. All pressure measurements within the duct system shall be made with static pressure probes, such as the Dwyer A303 or equivalent. And you guys have seen this pressure probe in previous PowerPoints as well, same ones that we can use for the duct blaster as well. Airflow rate measurements shall be made with an airflow rate measurement apparatus, which is the sensor plus data acquisition system, having an accuracy equal to or better than plus or minus 10% of reading. In the pictures that you see on the left hand side of the slide, on the top left picture you'll see an exhaust fan flow meter. On the right hand side you'll see a regular flow hood, and on the bottom you'll see a power flow hood. And we'll talk about this piece of equipment in a second. For calibration, all instrumentation used for mechanical ventilation system airflow rate diagnostic measurements shall be calibrated according to the manufacturer's calibration procedures. So double check what equipment you're using and figure out what the manufacturer's requirements are in order to calibrate it properly. Ventilation system airflow rate shall be measured using one of the following type of apparatuses, and we talked about these in a couple of slides before with the pictures that you saw. You can use a residential mechanical exhaust airflow measurement device, a power flow capture hood airflow measurement device, or a traditional flow capture hood. Let's talk about the exhaust airflow measurement device. A flow meter that meets the applicable instrument's accurate specifications as previously described can be used to measure the mechanical exhaust airflow. And on the right hand side you'll see a picture of an exhaust fan flow box, which is used in combination with a regular manometer, same as the manometers that you use in the duct blaster or the blower door. You can also use a powered flow capture hood airflow measurement device. It's a device that has the capability to balance the flow capture static pressure difference between the room and the flow capture hood enclosure and meets the applicable instrumentation specification as previously described. It may be used to verify the ventilation airflow as long as it has a flow capture area at least as large as the ventilation system of register grill in all dimensions. The fan adjustment needed to balance the flow capture static pressure difference shall be provided by either an automatic or manual control. The specific use for this particular piece of equipment has to do with the manufacturer's instructions. So each type of power flow hood will work differently depending on the manufacturer. And then you have a traditional flow capture hood. It shall meet the applicable instrumentation specification as previously described. It may be used to verify the ventilation system airflow rate if it has a capture area at least as large as the ventilation system register grill in all dimensions. So as we talked about in the adequate airflow section, basically in order to use a regular flow hood like in these pictures or the power flow hood like we show you in the previous picture, the flow hood has to completely cover the register grill of the mechanical ventilation system that you're about to test. And in these pictures you see the three pieces of equipment while they're being used. As you can see, each piece of equipment completely covers the grill that you're about to test. On the right hand side you'll see that on the very top the area of the flow hood doesn't quite cover the overall grill, because you can see the edges of the grill sticking out to the side. So that would be an incorrect way to test that particular system. The capture area of the flow hood, again, has to completely cover the grill that's being tested. So on the picture on the right hand side, even though that piece of equipment is correct, the way it's being tested is actually incorrect, and that would be a fail in that particular scenario. For the exhaust fan flow meter, in order to set it up, you want to connect the metering box to a pressure gauge. And it doesn't matter which pressure gauge you're connecting it to. You can work with both the Retrotec and Minneapolis gauge. You then want to select the door position on the metering box based on the flow range of the system, of the mechanical ventilation system that you're about to test. You will practice doing this particular test with a flow box when you're actually in your field training. So you'll be practicing this hands-on. This is just to give you an idea of what the equipment looks like and the setup procedures. Specific setup procedures for the gauge and manometer will be going through with you during the field training as well. You then want to attach the handle to the metering box. And then you want to press the metering box against the grill that you're about to test, creating a good tight seal around the edges of the box. The manometer, as shown in the picture, will then be able to give the reading of that particular exhaust ventilation system. For the power flow hood, obviously you want to assemble the capture hood based on your manufacturer's instructions. You want to attach the fan to the capture hood. You want to set up the pressure gauge to the flow hood as well. You will then hold the power flow hood to the grill that you're about to test, and then you will balance the pressure by activating the power flow hood. The gauge will then give you the reading. For the traditional flow capture hood, you're going to assemble the flow hood as instructed by your manufacturer's instructions. You want to attach the handle to the flow hood. On some models, the handles might be permanently attached, so it just depends on the model of the equipment that you're using. You want to set up the gauge for whatever test it is that you're doing. Most of these gauges are pre-set up, meaning that you just turn it on and it's going to default to the setting that you'll need for this particular test. Nonetheless, check with your specific manufacturer's instructions and operator's manual to figure out what the setting should be. Keep in mind that you're taking a flow reading, so it's always going to be in CFMs. You're always going to be taking a CFM reading. And just like the power flow hood and exhaust fan flow meter, you're going to be holding up the flow hood, covering the entirety of the grill that you're about to test. As far as the target values, prescriptively the targets will be calculated and transferred on the appropriate CF3R MEC 27. We went through all these calculations during the Title 24 overview section when we discussed mechanical ventilation. That's where the targets come from. Now, performance-wise, if they are using the performance approach, the values, the target values, will be just found in the certificate of compliance, which is the CF1R. So you'll be able to just look at the CF1R and figuring out what your targets are going to be. There are separate procedures for continuous operations and intermittent operations. And again, we talked about these two methods during the Title 24 overview section.
Approved systems, devices or controls, and field verification and diagnostic test protocols for whole house ventilation systems are listed in directories published by the Energy Commission. To be listed in that directory, the manufacturer must provide sufficient evidence to the executive director of the CEC that the installed mechanical ventilation systems, devices, or controls will provide at least the minimum whole building ventilation airflow required by ASHRAE Standard 62.2 and subject to consideration of the manufacturer's proposed field verification and diagnostic test protocol for these ventilation systems. So any system that you're going to encounter out in the field does need to be approved and listed in that directory that can be found on the Energy Commission's website. For field verification of continuously operating exhaust and supply ventilation systems, you will use one of the previously described apparatuses if the measured airflow is equal to or greater than the value for whole building ventilation airflow rate required by Section 4 of ASHRAE Standard 62.2 and listed on the CF1R. The mechanical ventilation system complies with the requirement for whole building mechanical ventilation airflow. If the measured airflow is less than the required whole building ventilation airflow rate, the mechanical ventilation system does not comply and corrective action shall be taken.
If you're working with a combination system, when a combination ventilation system is installed, the ventilation rate is considered the larger of either total supply airflow or the total exhaust airflow. The airflow rates of the supply and exhaust fans may not be added together. You're just going to be using the greater one of the two.
For intermittently operating systems, in addition to performing the test that we described in the continuous operation section, you'll also need to determine the number of minutes per hour the ventilation system is programmed to operate. Now, because the system, the ASHRAE 62.2 whole building ventilation rate is calculated based on a continuously operating system, when you do an intermittent system, it's going to need to provide more CFM in airflow than the continuously operating system does because it's running for a shorter period of time. So we need to be able to determine through a calculation if that additional airflow is sufficient to meet the continuous flow rate. So you'll need to perform the same test, collect your airflow, and also determine how many minutes per hour that fan runs, so that you'll enter that data into the CF3R, and it will perform that calculation for you to let you know if it meets that minimum requirement.
And now we're going to be covering the forms that have to do with this particular test. The CF3R MEC 27AH, it's used for continuous ventilation airflow, the fan vent rate method. The CF3R MEC 27B, continuous ventilation airflow, it's used for the total ventilation rate method. The CF3R MEC 27C is used for the intermittent ventilation airflow, fan vent rate method.
The CF3R MEC 27D is for intermittent ventilation airflow, total vent rate method.
As always, if you have any questions, just give us a call, shoot us an email, or please also contact us through the LMS messaging system.